Three people, you can get a lot of knowledge today. Word problems are usually one of those things that give people fits. Usually I see faces like this in the lab when we start talking about word problems. So it's a very good, yeah, so if you've seen that face in the mirror when you see the word problem, that's usually the face I see. The second page has some terms, or it's the back of your first page. It has some terms, stuff that you can translate, will help you translate word problems, and certain phrases there that might come up in some of the word problems you're dealing with. A lot of the word problems that involve number problems, these words are very helpful in setting those up. 4 steps to solving word problems. I have those written up here. We're going to use these 4 steps to solve our system of equations. And the rest of the pages in that handout, each page has a different word problem on it. So that's what we're going to go through today. So the first word problem we have is the sum of 2 numbers is 102. If 3 times the smaller number is subtracted from twice the larger number, the result is 49. Find the 2 numbers. So we have a problem that we really need to translate. It's like translating to another language, basically, because that's what math is. So we want to understand the word problem and define our unknowns. So what are the 2 things we don't know in this problem? They call our, we have 2 numbers. And specifically, they're giving each one of those a name. What types of numbers are they? They say one is a smaller number and one is a larger number. So which one would you like to call our smaller number and which one would you like to call our larger number? Does not matter. Which one? Okay. Someone took the initiative and said, let's call X our smaller number. And we'll call Y our larger number. So this is kind of just defining what we're really looking for in this problem. All right. The second step is we're going to write some equations that will help us solve the problem. So we want to write a system of equations with good information. The first sentence says the sum of 2 numbers is 102. What does the word sum?
Add.
Add. So we're adding something together. They're saying we're adding the sum of our 2 numbers. And what do we call those 2 numbers? That's one, our unknowns. So the sum of 2 numbers is 102. The word is means equals. So the sum of our 2 numbers is 102. The second sentence is going to give us our second equation. If 3 times the smaller is subtracted from twice the larger number, the result is 49. So it says we're having a subtraction problem here. What do we have to write first? 3 times the smaller number is subtracted from twice the larger number. Okay. So 2 times the larger number. So 2 times y minus 3x. Does everybody agree with that? 3 times the smaller number is being subtracted from twice the larger. The result is 49. So there's the 2 equations. We set them up, we translated our problem into 2 equations. Now we want to actually solve this. My suggestion is if you have x and y on the same side, you really want to write it so that if you do the elimination method, you want your x's and y's to line up. So I'm going to keep my first equation as x plus y equal to 102. how could I rewrite the left side of that second equation so my x's and y's line up and I don't change the meaning? Right, so if I wanted to put the x part first, we haven't changed the side, right? We still write it as minus 3x. Right, and this is a positive 2y. And that's going to be equal to 49. So I just kind of reversed the order of our x and y. Yeah?
Is this the
Workshop?
Yes, for 320. Yes. Make sure you sign in. All right, so how could I solve this equation? Does everybody agree that elimination would be the best way there? You have an x and y on the same side. So how could I use elimination to solve this problem? Okay. Someone said we can multiply this first equation by what? 3 would be the easiest, because I want to eliminate one of my variables. So I've already got a negative 3 here. So I'm going to multiply this first equation by a positive 3. So what does that make my first equation? If I multiply that whole equation by 3, what do I get? And 3 times 102? 306. I didn't change the second equation at all, right? So I'm just going to rewrite that one. Negative 3x plus 2y equals 49. Now if I add those two equations together, what's going to happen to our x's? Cancel each other out. 3y plus 2y? 5y. And 306 plus 49 is 355. Correct. And then my last step to figure out what y is would be to do what? Right, we're going to divide by 5. And so y ends up being what? 71. So we've got our y value, but we still need to find our x value. Which equation is the easier one to plug in? The top one. Which is to have x plus y equal to 102. So we found that y was equal to 71. So we're going to replace y with 71. So how can we get x? Okay. So x ends up being 31. So we think we have our answers, x equal to 31 and y equal to 71. But to really make sure, let's go back and check our answers. So let's go back to our first equation. What was x? What was y? Does 31 plus 71 add up to 102?
Yes.
Yes. So that checks. We also need to check the second equation. So 2y minus 3x equals 49. So if we replace y with what we got for y, which is 71, and replace x with what we got for x, 31, we should end up with 49. So let's see if we do. 2 times 71? 142. 3 times 31? And what does 142 minus 93, what does that add up to or subtract to?
49.
49. So it checks. So we know for sure that we got the right answer. Any questions on that one? We've got another one. The next one we're going to be able to translate as well. So if we didn't get this one, do the next one. first two steps. Yeah, the subtraction is the one that you have to be careful with, the order. Addition, not so much, but subtracted from means it has to come second. Because you're taking it away from something.
The answers for X and Y, are we writing those down as an ordered pair or writing them down as
No, because this problem was, it didn't say anything about where these two lines cross. They just wanted to know what the smaller number was, what the larger number was. So you could say, this is my larger number, this is my smaller number, and that's all you have to state. Okay.
We have to actually state it though, right?
Depends on the instructor, but you usually don't say, label what your answers mean. Okay. Everybody has third step.
Number 4.
Okay.
Okay.
Got it?
Yes.
All right. So the second problem is very similar. We're going to be translating them. It says the difference of two numbers is 27. If 4 times the larger is added to twice the smaller, the result is 162. Find the two numbers. So let's define our unknowns. Once again, our unknowns are specifically called a smaller and a larger value. Okay, so which one do you want to call the larger value? Which one do you want to call the smaller value?
X smaller.
Okay? It does not matter. You are determining what you want to call them. So we define our variables. So what does the first sentence say? The difference. Well, if some meant addition, difference has to mean subtraction. So we're going to do subtraction between those two numbers. The difference of two numbers is 27. So x minus y equals 27. Now let's think about this. If y is the larger number and x is the smaller number, can it be written like that? See, shake your head, why? Why is that?
So we have to reverse them then.
We have to reverse it. The reason why, yeah, if we take y, a larger number, away from x, we're going to end up with a negative number. And it's saying that we should end up with a positive number. So we have to reverse the order of what we're saying. So y minus x has to be the way that one is written.
So just change y and x, or just change what they represent?
Either way. But since we already defined this one as a smaller number and that one's a larger, I'm just reversing the order of our equation. This way, taking a larger number and subtracting a smaller number, ending with a positive value. So you have to reverse those. What does the second statement say?
4 times the larger is added to twice the smaller. 162.
Okay, so if 4 times the larger is added to
2 times.
twice the smaller, the result is equals 162. So there's our equations. Our x's and our y's are lined up. So we could use the elimination method. That's the easiest method to use here. How can I eliminate one of those variables?
Multiply the top by -4.
That's one way of doing it, yep. So let me rewrite that. You could multiply the top equation by -4 if you wanted to eliminate y's, so we could do that. What could we have also multiplied by?
2.
Yeah, 2, if we wanted to eliminate x's. Either way, it doesn't matter. So what does my new first equation look like? What's negative 4 times this equation going to give me?
Negative 4y
Okay,
plus 4x
right, the negative times the negative is plus.
equals negative 108.
Right, negative 4 times 27 is negative 108. I'm not doing anything to my second equation, so I'm just going to rewrite it. 4y plus 2x equals 162. And if I add those two equations together, what happens to my y's?
They cancel.
They cancel out, or they eliminate. Hence the elimination method. 4x plus 2x is 6x. And we have 162 minus 108, which gives us
54.
54. So if I divide 54 by 6, what do I get?
9.
So there's one of my values, specifically my smaller value. And if I wanted to figure out what y was, go back to the easier of the two equations, which in this case is the first one, correct? So y minus x equals 27. I know what x is. It's 9. So y minus 9 equals 27. And then if I add 9 to both sides, yep, y is 36. So there's my two values. So if we checked it, to make sure, y minus x equals 27. So 36 minus 9 needs to be equal to 27 for my first equation. Is that true? What's 36 minus 9?
Yes.
Yeah, 27. It checks out. The other one, 4 times 36 plus 2 times 9 should add up to 162. 4 times 36 is 144. 2 times 9 is 18. 144 plus 18 is 162. So it does check. A lot of instructors don't require that fourth step, but you know, it's always good to have a safeguard. Do I really know this answer is correct? And you know for a fact, if it checks, it is. So if you're like on a midterm exam or something like that, having that check in there, you know, you got that answer right. You know, you got those points. Any questions on that one or 1 to 4? They're kind of similar. Now the next few problems deal with different information. The next two problems we're going to be dealing with are rate problems, and we use a certain equation for that one, and then some of the other unusual word problems we'll get to. Any questions on that one? Can I erase? All right, so we have this river cruise boat, and it's traveling upstream at 40 miles. It's traveling 40 miles upstream, okay. The trip against the current takes 4 hours. The return trip with the current takes 2 hours. What is the speed of the boat in still water? In other words, how fast would the boat travel if there was no current? And what is the speed of the current? So a lot of information there, but what are the two things they're looking for? What are the two things that we don't know?
The speed of the current.
Okay? So I'm going to call x the speed of the boat. And that's the speed of the boat in still water. And what's the other thing we're looking for?
Time.
And what's the last question?
Current
Against
speed of current.
going upstream. Well, they didn't say downstream, they said upstream,
Of the current.
but
With no current.
Okay. So the two questions, the last two questions are asking, what's the speed of the boat is the first question, and the last question is what is the speed of the current? So we need to find the speed of the boat and the speed of the current. That's the two things that we don't know. So write a system of equations with the unknowns. If you're dealing with speed and distance and time, there's this equation, distance equals rate times time. You may have seen that before. Now, in order to come up with equations that kind of look with what we're used to, when you're dealing with the distance and rate and time problems, my suggestion is to rewrite it. Like this. Just reverse it. It'll help us come up with equations we're used to. Time times rate equals distance. So we have two situations here. We have a boat that's going upstream, correct? It doesn't specifically say downstream, but it says it goes upstream and it says the return trip. So if going upstream is this way, going back has to be downstream. So what was our time going upstream?
4 hours.
4 hours, right? 40 miles is the distance. So 4 times our rate. Well, our rates are here, right? Our speed of the boat and our speed of the current. Rate means the same thing as speed. If I'm going upstream, what can you tell me about the speed of the boat and the speed of the current? How are they affecting each other? So if the boat, right, if the current is going this way, if the boat's going upstream, is it going against the current or with the current? Upstream is against the current. So upstream, the boat is going, we'll pretend that's a boat, right? So we have a boat, if it's going upstream, it's going against the current. So that means that it's going downstream. It has to be going with the current. So for the speed going upstream against the current, the speed of the current is taking away from the speed of the boat. They're going in opposite directions. And that's going to be equal to the distance, which in this case, how far does the boat travel?
40 miles.
40 miles. So downstream, using the same relationship, time times rate equals distance. How long did it take going downstream? 2 hours, right? So if they're going against each other, it's x minus y. If they're going in the same direction, that means it would have to be x plus y. The current is actually adding to the speed of the boat. And it said that it made the same trip. So how far did it go?
40 miles.
40 miles. There's our two equations.
It's so good that you did it that way. Yesterday, our instructor did it the exact first way the whole time.
It looks weird if it's written the other way because you got the x and y on the other side. So I just kind of flip it around so it looks like something we've seen before. Okay, so let's write our equations over here and talk about how we need to solve these. So, where would we begin to solve this?
Distribute.
Okay. That is one way you can do it. All right. So let's distribute. So that first equation would be what if we distribute that? 4x minus 4y. And if we distribute that 2, plus 2y. All right, now we're back to doing what we did in the last two, elimination. So how could we eliminate one of those variables?
Multiply the bottom by -2.
You could do that. You could multiply the second one by -2. What if I wanted to eliminate y? What would I multiply it by? You're saying you can only, it's your choice, but
Yeah,
just 2, right? Somebody said, let's do -2 to eliminate the x's. You can eliminate either one, it does not matter. So the first equation is (4x minus 4y equal to 40. What happens to that second equation? What does that become? -4x. And then -2 times 40. -80. So what happens to our x's if we add those two equations together? They cancel out, they eliminate. So I've got -4y and -4y, -8y, 4 minus 80, it's -40. So y ends up being a +5. What happens if you come up with a negative number on that kind of problem? Go back and check your work. You don't want a negative speed, right? That's some issues. Or you're going to boat, trip down boat somewhere. So let's go back and figure out what x is. You can go back to either equation. My suggestion is to go back to one of these two, rather than using one of the original ones with the parentheses. It'll work out. This one's just a little less complicated. And I'm going to go with the 2x plus 2y equals 40, mainly because the numbers are small. So I'm going to plug in 5 for y. So 2x plus 10 equals 40. So I need to subtract the 10 first, correct? So 2x equals 30. And if I divide both sides by 2, x equals 15. All right, so my current is 5 miles per hour, correct? That's what y represented. And the speed of my boat, 15 miles per hour. What happened if it would have worked out and the current was more than the speed of the boat? 1, you're in trouble because your boat's out of control. 2, go back and check your work, because in all these types of problems, the speed of the boat's always going to be bigger than the current. So make sure that, that's another kind of double check. I'm kind of going to skip the check step because we've done 3 problems in about 30 minutes. I want to make sure we get down the road to some of the other ones. Okay. Any questions on that one?
Could you use another method to solve? Or
Yes, you can always use elimination or substitution. My opinion, if x and y are on the same side, I would always use elimination. All right. Can I erase this information? The next one talks about an airplane. We have a commercial jet that's traveling between 2 cities that are 900 miles apart. The trip against the wind takes 2 hours. The return trip with the wind takes 1.5 hours. What is the speed of the plane in still air? In other words, how fast would the plane travel if there were no wind? And what is the speed of the wind? Is this very similar to the boat problem, right? except instead of upstream and downstream, you have against the wind and with the wind. So, we'll say x is the speed of the plane. And we'll say y is the wind speed. Write a system of equations with the unknowns. So we can use the same relationship that we did last time. Time times rate equals distance. So instead of upstream and downstream, we have against the wind and with the wind. Okay, so against the wind, how long did it take?
2 hours.
So 2 times, well, against the wind is kind of like going upstream. It was against the current. So it would be x minus y, right? The wind speed is slowing the plane down. And how far was that trip? What was the distance? 900 miles, correct. So going with the wind, how long did it take? 1 1/2. My suggestion is kind of go away from the mixed number and write it as 1.5, 1.5. The 1.5 is going to be easier to deal with. And if we're going with the wind, that means the wind speed is actually making the plane go faster. So you're going to add the wind speed to the plane speed. And that trip was also 900 miles. So let's solve the system. You said we could use the distributive property, right? Get rid of those parentheses. So 2x minus 2y equals 900. And then I've got 1.5x plus 1.5y equal to 900. Now, if you don't mind the decimal, you can always kind of work with them, but it's usually easier to get rid of them, to make them into whole numbers. So what can we multiply that second equation by to clear our decimals up? 10. Our decimals are in the tenths place. So, we didn't do anything to that first equation. All right, we're not even to the elimination stage yet. We're just making our equations a little bit easier to use. So 10 times that second equation, what's that going to give us?
213x
Plus
15y.
equals? Remember, you got to multiply that. Yep. You got to multiply that number at the end by 10 as well. So now we need to solve this equation, these two equations. Any suggestions on what would be easiest to eliminate? If not, I have one.
Substitution?
Oh,
You have to eliminate, right?
Yep. I always look at the numbers that have opposite signs.
30?
Yep. What times 2 gives me 30?
50.
15. What times 15 gives me 30? 2. So in this case, I really want to multiply both equations by a number. 15 times the first one, and 2 times the second one. So what's my new first equation? 15 times that equation is?
30.
30.
30 x.
And 15 times negative 2y is negative 30y, right? 13,500.
Yeah.
Okay. And 2 times the second equation is 30x plus 30y. And 2 times 9,000 is 18,000. So if I add those two equations together, what's going to eliminate?
One.
My y's, which is what I wanted to do. And I have 60x equal to 31,500. So we need to divide that by 60. Hopefully it goes evenly. 525. That sounds like a good number. Sounds like a good plane speed, 525 miles per hour. Now I need to find the wind speed. My suggestion is to go back to the easiest equation, which I really think is this one, the 2x minus 2y equal to 900. So 2 times 525 is 1050 minus the 2y equals 900. If I subtract 1050 from both sides, I get a negative 2y equals a negative 150, correct? And then my last step there would be to divide everything by negative 2. So y ends up being
75.
75.
75 or negative? No.
Yeah, because we're going to have a negative divided by a negative there. So 75. Right. Like I said, I'm going to skip that check step just for time's sake. But do our answers make sense? That's also another good check.
Yes.
Right. 75 miles an hour, that's kind of a high wind speed, but you know, you're up there. The wind speed's going a little higher. If my plane speed was much lower than the wind speed, one, you're in trouble. I mean, plane's going down. But you know, the answer should make sense. And in this case, it does. So 525 miles per hour. Our wind speed was 75 miles per hour. Any questions on that one? Very similar to the last one, just a little bit different information dealing with a plane there, but the situations can be set up exactly the same.
I have a question.
Yes?
What if you had 1.5 and then 1.5 and another number? What would you multiply that equation with if it's not? Is it right there where you multiply it by 10?
Well, these were all in the tenths place.
Right.
Okay. So if you have multiple decimals, you always use the largest amount of decimal places.
Okay.
So if you have 1 in the tenths, 1 in the hundreds, 1 in the thousands,
Mhm.
you can multiply the whole equation by thousands.
1,000, okay.
Yep. Good question. All right. Everybody good?
Yeah.
Just want to remind everybody there's a whole bunch of sandwiches and chips and drinks over there. If you want to have some, please do. All right, big paragraph for the next one. It says, for the concert on campus, advance tickets cost $15 and tickets at the door cost $20. The ticket sales this year came to $6,250. The activities coordinator wants to raise prices next year to $17 for advance tickets, $25 for tickets at the door. She said that if exactly the same number of people attend next year, the ticket sales at these new prices will total $7,375, if she is correct. How many tickets were sold in advance this year? How many tickets were sold at the door? A lot of information there, right? Well, let's break it down step by step, see if it makes sense. So, we're going to understand the problem and define our variables. Well, the variables are defined in the last two questions. What are the two things we don't know? What are they looking for?
How many tickets were sold in advance this year?
Okay. So we'll say X is the number of tickets sold in advance, correct? And Y will be the other question. That's the number of what? Tickets sold at the door. So we have two situations. We have one situation, which is this year, right? Which is now. And our second situation is next year. Okay? So this year. And then next year. So we're coming with a total dollar value for this year of what? What was the total as far as money? 6,250. And next year they say if we sold in the same number of tickets, we'd end up with how much money? 75. Well, that's a dollar amount. So we need the dollar amount of the tickets. So what was the dollar amount for the tickets sold in advance this year?
15.
So 15 times X, our unknown, right? Plus, how much per ticket sold at the door? 20 times the number of tickets sold at the door. Makes sense? What about the second equation? The next year they want to raise the prices. So what's the price of every ticket sold in advance next year? So 17 times X. Right, we're selling the same number of tickets. Plus, how much for at the door? There's your two equations. Numbers are kind of big, but the hard part's over. The setup is the hardest part. All right, so there's our two equations. I know I'm kind of spread out over here. So let's say we got 15x plus 20y equals 6250, 17x. We want to eliminate one of the variables. I would definitely go with elimination on this one. If you try to do substitution, you're going to introduce some fractions you probably don't want to see. Any suggestions on what letter we should eliminate?
One.
Y. I would say Y mainly because there's an easy number to find between 20 and 25, and that's 100. How many times does 20 go into 100? 5 times. So let's multiply that equation by 5. How many times does 25 go into 100? 4. Now I need the opposite sign for them to eliminate. So I'd have to multiply this by -4, correct? So what's my new first equation? 5 times 15. So 75x. 5 times 20. 100y. 5 times 6250 is 31,250. 31,250. -4 times 17 is -68. -4 times 25 is -100y. This is 29,200. -29,500. Okay, thanks. So our y's eliminate. Our goal was to eliminate one of those. 75 minus 68.
7x. Yeah.
7x. 31,250 minus 29,500. 1,750. Is that correct?
Yes.
So I need to divide 1,750 by 7. And that is 200 and how much? 250. So how can I figure out the other variable? How can I find out y, the number of tickets sold at the door? Plug it in. It doesn't matter which equation. In this case, not really. They're both kind of big numbers. So 15 times 250 plus 20y equals 6250. 15 times 20, or 250 plus 20y. So we need to subtract 3750 from both sides, correct? So that's 20y equal to 2,500.
Yes.
So y ends up being 125. Let's get the checks out. That will work out, I promise. And also I ran out of room. So. But if you would put those in place, the number of tickets for in advance was 250, and number of tickets at the door was 125. So make sure as you're putting your answer, that's what you're looking for. Okay, we might be able to fit one more in. Let's see. What do we got left? We've got concert. We've got acres of land, football, and the circus. Let's take a vote.
Football.
Oh, football. Somebody said football. All right, let's do football. All right. If you want to go over any of the other ones, feel free to stop by in the lab and any one of our tutors, including Jessica here. Would love to be able to help you with your word problems. That's what we do. All right, so please take advantage of it. So let's skip on over to that football question and figure that one out. Everybody has this one. Any questions? Oh, okay. You have a chance, if you could get that evaluation.
Oh, yeah. Sure.
Just face down right here. Thank you very much. Hope it helps. Yeah, if you guys need some help on those three ones, very variables, just help them up, okay?
Okay.
All right. So it says during the 2010 Pro Bowl between the American Football Conference and the National Football Conference, 66 points were scored in touchdowns and field goals. The total number of touchdowns, 6 points each, and field goals, 3 points each, was 13. How many touchdowns, how many field goals were scored? So if we're setting up our unknowns, what are the two things we're looking for? What are the two things we don't know? Always look at the questions at the end of the problem. How many touchdowns and how many field goals?
So X is touchdowns?
Whatever you want to call it. One has to be touchdowns, one has to be field goals. Feel free to call whichever one. I'm going to use X as the number of touchdowns. That means Y has to be the number of field goals. All right, so we have two situations here. They give us the number that was scored altogether of touchdowns and field goals. So the number of scores. And they also give us the point value of all the scores combined. So as far as the number of scores, how many were there? Well, that was the points. So how many scores were made? Well, it says the total number of touchdowns and field goals was 13. So as far as the number of scores, there was 13 altogether. We just don't know how many of each we had. So X plus Y has to be equal to 13 as far as the number of scores. The point value of the scores. How much is a touchdown worth? 6 points. So 6 times X. How much is a field goal worth?
3 points.
3, so 3Y. And the total number of points scored altogether, 66. Okay. So there's our two equations. Not nearly as bad number-wise as the last one. So if I want to solve that, elimination is probably the best way to go. You could get away with substitution on this one, but I'm going to stick with elimination. What letter do you want to eliminate? Okay. And to eliminate y, what would I have to multiply that first equation by? It could be x. I just heard a large multitude of y's held up here. So what would my first equation be?
Negative 3x.
Minus 3y. And negative 3 times 13?
39.
Negative 39. I didn't do anything to that second equation. 6x plus 3y equals 66. What happens to the y's? They cancel out, they eliminate. Negative 3x plus 6x is 66 minus 39, I think it's a big deal now. 27, yeah. So x ends up being what when I divide both sides by 3? 9. The easiest equation here is that first one, x plus y is 13. So 9 plus y equals 13. If I subtract 9 from both sides, y ends up being 4. So, how many touchdowns were scored? 9. 9 touchdowns. How many field goals were scored? 4. On a problem like that, if you come up with a negative number, you go back and check it out, right? Because you can't score negative points. Texans defense is good, it's not that good. You can't score negative points. So if you get an answer that doesn't make sense, make sure to go back and check your work. It's another trick that you can use. Thank you guys for showing up. I hope it helped out. If you want to go over any of the rest of them, feel free to bring those by the lab and we can go over those. Okay.
Do me a favor, man. Need you to sub for my teacher at least every week for the next semester.
Pretty sure
Because it'd be easier to understand. She rambles a lot.
Thank you.
She gave you bad marking skills.
Oh. I'm sure it's like Jessica's paper on this. Thank you very much. Thank you. See you tomorrow.